Hey, this is lesson 14.3, found on page 640 in your textbook. And here we're talking about the Pythagorean Theorem. The Pythagorean Theorem was discovered by, or named for, Pythagorean, which is this guy right here. Pythagoras was a Greek mathematician and philosopher who discovered one of the most famous rules in mathematics. In mathematics, a rule is called a theorem. So the rule that Pythagoras discovered is called the Pythagorean Theorem. And it's for this guy who lived more than 500 years BC, which means this guy's over 2,500 years old, which is like Mr. Mendolia was just a boy when that guy was around. That's a long time ago. The key ideas here, the right sides of a right triangle. This only works for right triangles. So don't try this with any other right triangles, only right triangles. The sides of a right triangle have special names. The two sides that come together to form the right angle are called legs. So this could be leg A, leg B. The side across from the right angle is the hypotenuse. Now the hypotenuse is always the longest side in a right triangle, because it's across from the largest angle. The right angle has to be the largest angle in the right triangle. The side across from it, the hypotenuse, will be its longest side. So the two legs are always the shorter of the two sides, and the hypotenuse is always the longest of the three sides. Pythagorean's theorem. In any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse, which seems pretty straightforward and easy to me, but I'll explain it anyway. In algebra, it looks like this: a squared plus b squared equals c squared. That means if you take this length and you square it, and you take this length and you square it, and you add those two together, it will equal this length squared, okay? A squared plus b squared equals c squared. And I really like this graphic that goes along with it right down here. See, they take this triangle, and instead of just saying a squared plus b squared equals c squared, they show it this way. If you take this length and you make a square out of it, so instead of just a 2, it'd be a 2 by 2 square, and you take this length and you make a square out of it, and then you take this length and you make a square out of it. If you add these two areas together, it would equal this green area. So this blue area plus this red area plus this blue area, if you put them together, you would get the same area of this green square. Okay, a squared plus b squared equals c squared. Let's see if we can use it, and maybe it'll make a little more sense if it doesn't already make sense to you. So find the length of the hypotenuse. So we've got this leg, and then an unknown. The hypotenuse length is unknown. So we just use a squared plus b squared equals c squared. We don't know the hypotenuse, so that'll just say c squared. But we do know these two. It doesn't matter which order you put them in, so we'll just count the 5 as the a. So we'll have 5 squared plus 12 squared equals c squared. 5 squared is 25, and 12 squared is 144. That equals c squared. If I add these two together, I get 169 equals c squared. And now, to solve this, and we did this before when we were talking about squares, we just take the square root of each side. Well, the square root of c squared is just c. And what times itself is 169? 13 times 13 is 169. So if c squared is 169, then c is 13. So you have a 5, a 12, and this has to be 13. Now, a quick check. It does have to be longer than both of these. So it's longer than either of these, but it cannot be longer than these two added together. So 5 plus 12 is 17. So it has to be larger than 12, but less than 17. And it is. So yay, we are brilliant. Thank you, Pythagoras. Okay. You don't really have to say that every time. Let's try it out on these two on your own problems. And we'll write the formula or the Pythagorean theorem here. A squared plus b squared equals c squared for number 1. How does that look? Well, we're looking for the hypotenuse, so we'll write c squared. We're still looking for that. We have 8 squared plus 15 squared equals c squared. This is 64, of course. 15 times 15 is 225. Add these together and you get 289. And what times itself again gives you 289. 17 times 17. So what times itself, not cubed, sorry. What times itself is 289? 17 times 17 is 289. So square root of each of these, c equals 17 feet. Number 2, a squared plus b squared equals c squared. We're looking for the hypotenuse here. And this time we have 3/10, and I'm going to put squared, plus 2/5 squared. Well, what's 3/10 squared? It'd be 9/100ths plus, and this would be 4/25 equals c squared. I need a common denominator, so this would be 9/100ths plus 16/100ths equals c squared. Add these together, I get 25/100ths equals c squared. Now I could simplify that right now to 1/4, or I could do the square root of each of those first. I'm going to simplify it first to get 1/4 equals c squared. Now I'm going to take the square root of each of those. This will obviously be c. What times itself is 1/4? Well, the square root of 1 is 1, and the square root of 4 is 2. So c equals 1/2. Had I done the square root here, square root of c squared is c. The square root of 25 is 5. And the square root of 100 is 10. And then we would have simplified 5/10 down to 1/2. So it didn't really matter if I did the square roots here. I like to simplify before I do that, and I get the square root of 1/4 is 1/2. So the length of c is 1/2. It has to be longer than either of these, and 1/2 is longer than either of these, but less than both of these added together. And this would be 4/10 plus 3/10 is 7/10. And 5/10 is less than 7/10. So yes, shorter than the sum, but longer than either of them. Now sometimes the hypotenuse is given, and it's one of the legs that we have to be looking for. So here we're looking for a missing leg. So we use a squared plus b squared equals c squared, of course, and we fill in what we know. This time we know the hypotenuse, or c is 2.9. So we put 2.9 squared over here. We know one of the legs is 2.1, so we put that in for one of the legs, 2.1 squared. And then we don't know the other leg. In this case, it's the a squared. So now we have a squared plus 2.1 times 2.1 is 4.41. And 2.9 times 2.9 is 8.41. So a squared equals 4.41. A squared plus 4.41 equals 8.41. Subtract 4.41 from both sides, and you get a squared equals 4. Take the square root of each side, a equals 2. Okay, so this would have to equal 2. It has to be less than the hypotenuse. Okay, it has to be less than the hypotenuse because that's the largest of the sides. So let's try a couple of those on our own down here. Number 3. A squared plus b squared equals c squared. We have c, so 34 squared. And they gave us a. It doesn't really matter a or b, but they gave us b here. So this is A. So 16 squared plus B squared equals 34 squared. Now I cannot subtract 16 from each side and make this, 16, 18 squared or anything like that. I actually have to square these. So 16 times 16 is, I don't know, 36, 6, 7, 8, 9, 0, 1, 6, 6, 5, 256 plus b squared equals 34 squared. And if I didn't know what 16 squared was, I definitely don't know what 34 squared is. 34 times 34, 16, 12, 13, 0, 12, 9, 10, 6, 5, 1, 1, 1, 5, 6. Subtract 256 from each side, and we get b squared equals 900. Take the square root of each side. This one is obviously just b, and 30 times 30 is how we get 900, so b equals 30. 30, which is shorter than the hypotenuse, so we're still good. Excellent, 30 yards. And number 4, do right here. So number 4, a squared plus b squared equals c squared. And in this case, the hypotenuse is our 10.4. So 10.4 squared here. A is over here, so that's a squared plus, and 9.6 squared for b. All right. So a squared plus 9.6 times 9.6 is 92.16. And 10.4 times 10.4 is 108.16. When I subtract 92 from each side, 92.16 that is, subtract 92 and 1600ths from this side, you're left with a squared over here and 16 over here. Take the square root of each side, and a equals 4 meters. Now you can head over and do journal page 336 after watching the video for that journal page, which is for lesson 14.3, journal page 336.